Okay, let's take a look at this first example. In this first example, it says yesterday it was 74 degrees outside, and today it is 82 degrees outside. And it wants to know what is the difference between the temperatures. Well, what is the difference between the temperatures? I bet you that's really easy for you to answer. You'd probably go, well, the difference is the difference between 82 and 74. So you'd probably go 82 minus 74, and you'd get 8 degrees. And that would be correct. So let's talk about this word difference. Because we just found the difference between 82 and 74. That's what we just answered. The word difference means subtraction. The word difference is the answer to a subtraction problem. Again, I want to talk about this word and I actually put it in symbols. I'm going to take it out of symbols and put it in, and write the whole word out just so you can see. Okay? This word and, again, told us where to put the subtraction sign. So difference told us to subtract, but and told me where to put the subtraction sign. So it's 82 minus 74, and that's where you got your 8 degrees. Now let's talk about this. I'm going to talk about some of the words they use for subtraction, but I have to tell you, you don't use a lot of this in algebra. You use this in arithmetic a lot. Again, this answer is the difference. This number is called the subtrahend. Again, we don't use that a whole lot. And this number is called the minuend. Those words are nice. I really want to call them terms. Okay? Terms is a really important word in algebra, and terms are separated by a plus or a minus sign. And that's what's really important. So for me, I really want you to understand that 82 is a term, 74 is a term, and 8 is called a difference. That's what I want you to know about this problem. And that becomes really, really, really important. Okay, let's look at the effect of 0 on subtraction. Okay, let's say we have 35 minus 35. Well, we know that's 0, but is that always true? When you take a number and subtract itself, will you always get 0? Clearly, that's always true. So that's one of the subtraction properties of 0, that when you multiply a number by itself, sorry, not multiply, when you subtract a number from itself, you're going to get 0. So this is a math example, or an arithmetic example, and this next one is an example in algebra. I can let a be any real number, and I would say a minus a equals 0. So when you take a number, subtract itself, you will get 0. Okay? Now take a look at this next example. 76 minus 0. Again, clearly, 76 take away nothing, or 0, is still going to give you 76. That's another property of 0, that whenever you take a number, let's call it a, let a be any real number, and you subtract 0, you get a. So in algebra, a minus 0 is a. That means it works for any real number. This tells me it works in this example. This tells me it works in any real number. Okay, now let's take a second to do some actual subtraction, and then we'll talk about the key words in subtraction. So let's look at some of these questions. From 25, subtract 12. Okay. If you have from 25, subtract 12, you've got to think about which number goes first. Well, if you're taking from 25, that means you already have 25. So what you have to understand about the word from is anything after the word from goes first. So 25 goes first. So 25 subtract 12 is the way this looks. And of course, this is easy enough. 5 minus 2 is 3. 2 minus 1 is 1. and we get 13. But the important thing is not that we can subtract 25 minus 12. You obviously can do that. The important thing is the fact that anything after the word from must go first. That's really, really, really important, especially when we get into the more intense algebra problems. Okay, subtract 16 from 41. And again, I want to keep that problem up there so you can see how this relates to that example. Subtract 16 from 41. Again, we said whatever comes after the word from must go first. This tells me that 41 will go first. So we have to have 41, subtract this from this. We have to have this in order to subtract this. And of course, we're going to have to do a little borrowing here, okay, because we can't subtract 6 from a 1. So we borrow, we make that a 3. There's your 11. 11 minus 6 is 5. 3 minus 1 is 2, and we get 25. So again, whatever comes after the word from goes on top, the important part of that. Okay. I want to put these next two up at the same time, and maybe you can see the difference. Okay. This next one says 7 less than 10. Okay, and this next one after that says 10 less 7. They're not the same thing just by virtue of what they say. One has a than in it, one does not. So let's look at 7 less than 10. Let's see if it's different from this problem. 7 is less than 10. You know who's sneaking in there, right? Again, look at that. That is dude. It's coming in again. That is tells us, followed by the less, followed by the then, tells us we have a comparison symbol. So this is 7 is less than 10. That's that problem. This does not have the is, so it is not a comparison symbol. That is an operational symbol. So the is takes an operational symbol and turns it to a comparison symbol. So be careful about that is word. Okay, so let's do that. 7 less than 10. That again means that I have to have 10 so I can have 7 less than that. So this is 10 minus 7. So this phrase less than switches the order. Whatever comes after the phrase less than must go first, just like the from. From works just like this less than. From and less than are the two words you have to be really careful of that will switch the order. 10 minus 7 is 3. And that's the answer to that one. 10 less 7. This is a word that doesn't happen a lot, but that means I have 10 and I have to get 7 less. So that's 10 minus 7, and that's 3. So what I really want you to get out of this whole thing is that anytime you do any of these symbols to words, or words to symbols, I should say, you always can go word for word unless you have the word from or the phrase less than. Then you must, absolutely must, switch the order. And let's just for 1 second talk about commutative property with this. 10 minus 7, if I switch the order, 7 minus 10, I'm not going to get the same answer. 10 minus 7 will give me 3. 7 minus 10, we'll talk about later what that gives me, but it's not 3, okay? Because I can't, from 7 things, take away 10 things. Okay, let's look at one more example for the words. Let's look at the difference. The difference of 10 and 7. Of 10 and 7. Okay, here comes that word difference again. That does mean subtraction, but that's not where you put the subtraction sign. You have to look for the and. Here's the and. Here's where the subtraction sign goes. So it's 10 minus 7. Okay? Remember, the only thing that's going to change the order on us, it goes word for word here. 10 goes first because you see the 10 first. 7 goes second because you see the 7 second. The only thing that's going to change the order is the word from and the phrase less than. So this clearly is 10 minus 7, which is 3. So let's just kind of, for 1 second, review these keywords, and they're in your workbook. So let's see what we can do here. All right. So we learned a couple of them. The key thing here is those two phrases that switch the order. Keywords for subtraction. Remember, math isn't language. You got to keep going over these keywords. Okay, so the first keyword let's talk about is difference. The difference. Let's try between 6 and 2. Okay? Well, notice difference means subtraction, 6 and 2. That's what it would be in symbols. Next word or phrase is decrease by. We haven't used that, but it'll come up in algebra. Decrease by. And we might have 6 decreased by 2. Which is 6 minus 2. Again, no order's changing. What you see first is going first. 6 is first, 2 is last. Another phrase or word is less. 6 less 2. Again, what you see is what you get. 6 less 2. And then finally, the last two phrases that we did speak about, the big ones, is, let's go, 2. I think in your notes it says, oh, it does just say from. 2 from 6, which is, remember, changes the order because of the word from. So it's going to be 6 minus 2. Oops. Sorry. Goofed up your chart. Apologize. Let me fix your chart. Okay. Let's go from. Okay. 2 from 6, which is 6 minus 2. Again, changes the order because it's the word from. And the last one is the phrase less than. Less than 2 less than 6, which is again 6 minus 2. So those are the kinds of things you want to be conscious about, so you know that you can go word for word up to, from, or less than. The only things you have to worry about. And that's really important because, again, subtraction is not commutative. It will matter what order you subtract those numbers in. Okay, so now let's try some harder problems in subtraction. Let's just remind you how to subtract. I know you know that, but in this day and age where all we do is use calculators, sometimes we forget how to borrow. You can't steal in subtraction. You have to borrow. So stealing doesn't work. All right, so let's take a look at this. Again, the hardest thing that people find about subtraction is when they have to borrow from zeros. We'll talk about that. Okay, so let's take a look at this first problem. Subtract 10,362. Did I say and? I hope I didn't. 10,362. Shouldn't say and. From 19,216. Okay, so let's set this up. Again, up to you if you want to put it on graph paper or if you want to make lines so you can see it. Absolutely up to you. If it's not a problem for you, then you don't want to do that. That's the one thing you definitely don't want to do. Let's try that again. This is why I use a board. It's why I use pencil. Okay, I'm scared to do it now. I'll try. Here we go. Straight as an arrow, huh? Okay, so we're going to subtract. 6 minus 2 is 4. You can't take 6 away from 1, so we're going to have to borrow. So we borrow, that becomes a 1. 11 minus 6 is 5. Cannot take 3 from 1, we have to borrow. 11 minus 3 is 8. And then 8 minus 0 is 8. And then there's nothing there. So it's 8,854. Okay? So that's not really too difficult. But now let's go to those zero problems. Those are the most fun. Okay, let's try example 2. Now what makes example 2 fun is you're actually subtracting with zeros. You're not dividing with zeros. We'll do that later. We're actually subtracting with zeros, and there's an easy way to do that. So let's take this number 3002 and subtract the number 985. Okay, now watch this closely. It's kind of cool. Okay, you cannot subtract 5 from 2. So what you have to do is you have to borrow. But the problem is you can't borrow from 0. And usually a lot of people have trouble with this. So I'm going to tell you to box in everything until you get to the 3, to the first non-zero digit. That's the first digit that's not 0. So you want to stop the box there. Then what you're going to do is you're going to borrow from this number. Well, it's easy to take 1 away from 300 because 300 subtract 1 is 299. So this becomes 299, and then you carry the 1 right there. So now you have 12 minus 5, which is 7, and then 9 minus 8, which is 1, 9 minus 9, which is 0, and you got 2 minus nothing, which is 2. So you got the number 2017. And of course, we can show you later that you can check this by adding, okay, because the opposite of subtraction is addition. Now, number 3, we're going to have another one so you can see another example of this. So let's look at 5,000 minus, and this is 2,549. Okay. Again, you can't take 9 away from 0, so I'm going to box in everything. I'm going to use a different color so you can see the box. You're going to box in everything until the first non-zero digit. So now you're actually borrowing from the 500. So 500 minus 1 is 499. Carry the 1, so now you have 10. 10 minus 9 is 1. 9 minus 4 is 5. 9 minus 5 is 4. 4 minus 2 is 2. So you have the answer, 2,451. So that's how you subtract with zeros. Just box it in. Instead of worrying about what do these numbers become again, box it in until you get to the first digit that's not 0. It's called the first non-zero digit. And then you can just take 1 away from there. I hope you enjoyed subtraction. I hope you learned something about subtracting with zeros. And our next lesson will be estimating and rounding.